Opie wants to look at the difference between simple and compound interest. He decides to use $10,000 as a nice round number to use as the initial investment, and 10% per annum as a good figure to use to compare the results. For compound interest, the compounding will be once per year, annually, so n equals 1 in the formula. Opie designed the table below. Fill it in to compare the two types of interest. So at the start of year 1, he has $10,000, and that's the same for compound interest as well. So they both start with 10,000. Now 10% of 10,000 is 1,000. So at the end of the year, in both of these, we have 11,000. So simple interest and compound interest give the same result at the end of the first year. But that's when it starts to differ. Now I'm going to do the simple interest first because we only ever pay interest on the principal. In other words, we only pay interest on this 10,000, which means all the way down, the interest is going to be 1,000. So all the way down, the interest is 1,000 for simple interest. And then it's very simple to see what's going to happen. This will be 12,000. We'll start with 12,000 here and end up with 13,000. This will start with 13,000 and we'll get 14,000. Then we'll start with 14,000 and we'll get 15,000. Start with 15,000 and get 16,000. 16,000 will go up to 17,000. 17,000 would go up to 18,000. 18,000 would go up to 19,000. And finally, 19,000 will go up to 20,000. So our final figure for simple interest would be 20,000. Now this is more complicated, and I'll just use the ordinary calculator for this, with compound interest, because we start with 11,000, but for compound interest, we get interest on previously earned interest. So we get interest on all of that 11,000 in the second year. So we've got 11,000. So to get 10%, just times by 0.1. And so I get 1,100 interest. And then add that onto the 11,000. And we've got 12,100. So you can see already after 2 years, we've got more interest. And then we're going to get interest on 12,100. So I'm going to multiply that by 0.1. So I get 1,210. And then I need to add that to 12,100. And I've now got 13,310. So you can see earning interest on previously earned interest makes quite a big difference. Now you don't need to see me do all 10 rows of the table, but you might be interested in how different it is by the end. So if I start with 10,000, that's the initial 100%. I'm getting 10% interest each year. So to get 1 year's interest, I can multiply by 1.1. I would then multiply the result of that by 1.1 and the result of that by 1.1 and so on. Now that's going to give me the final amounts in the account, not the interest. If I do that to the power 10, that's going to give me 10 lots of interest. And so my final amount here is $25,937.42. So you can see the comparison. Because we got interest on previously earned interest, you end up with a lot more in the account with compound interest. Now, in the introduction, I've been making a bit of a fuss about how simple interest and compound interest formulas give us different things. So I'm just going to use the E activity here. I'm going to be wanting to find interest. The principal is 10,000. The rate he's using is 10%. And he's doing this for 10 years. Calculate the interest and we get $10,000. So altogether you can see here $10,000 of interest giving us a total of $20,000. But remember, this gives us the interest. So to work out the total amount, you have to add the principal of 10,000 to the interest of 10,000. Now, if we go for the compound interest formula, we're doing this annually, so I mentioned that n was equal to 1. The rate is 10%. The principal is 10,000. We're doing this for 10 years. And final value is exactly what we have here. 25,937. And I think we'd round that to 43 cents. And we've rounded to 42. It's 1 cent. But that gives us the final value. So if we wanted the interest, we would have to subtract 10,000 from that. And so we would see that the interest earned would be $15,937.42.